So, in OpenOCD, we're going to use two config files to latch onto the SWD interface. So the first one, f, and then interface /stlink-v2.cf, because again, our interface is the ST-link. And then /f, target/nrf51.cfg, because Bluetooth module is basically just an nrf51. So if we run that, hopefully, yes, OpenOCD has now connected to the SWD interface and has spawned a telnet server on port 4444 and a GDB server on port 3333. So I don't really know how to use GDB, so I'm just going to skip that because the telnet thing works great. So we'll just telnet in, port 4444, and there we go. We have access to the on-chip debugger. So we're just looking to dump off the firmware and put some new firmware on. There are a whole host of other commands, like you can just run help to get all of them, and there's tons of them. All we're interested in is dump image, and I think it's flash. So the first one dumps the image. But before running that, we'll want to run reset halt, just to make sure that the MCU is not getting in our way. So we'll just halt it and stop execution. So now we can run dump image, and this takes three parameters. First is a file name, second is a base address for memory, and the third is the end address for the flash memory. After much Googling, reading documentation, and eventually Stack Overflowing, I came to the conclusion that the addresses are 0x0 and 0x40,000. So if we enter all that info in, call it original.bin 0x0, 0x40,000, run that to start dumping the firmware. And now that we have the firmware, if we didn't have source, we could start reverse engineering it. I think in IDA Pro, the entry point should be around 0x10,000. So you just open it up, navigate to 0x10,000, press C, and boom, there's tons of code to look at. But since we have source, I'm not going to bother doing all that. All we're going to do is take a new compiled version with all the new extra goodies and slap that onto it. But that, I believe the command was flash. Let me check real quick. And oh, the command we want is program. We'll run program and then a file name. In this case, that would be firmware.hex, and it needs to be a .hex file, as in all of the data is in a special ASCII printable format. Normal binaries will not work with program. There are other ways of doing that. Since we have a hex file, it's so much easier. We're also going to specify verify to make sure that nothing goes terribly wrong, or at least if it does, we know. So we'll let that run. Got an error. Question is, why? So, and argument. Interesting. Probably because I misspelled verify. Hit that shot again. There we go, that's much better. Let that do its thing. There we go. It should have erased all of the existing flash, put our new firmware on. Now it should be pretty much good to go. Run reset real quick, just in case. Sometimes it gets angry if I don't. So now at this point, it should be completely good to go with the new firmware. Again, if we wanted to play around with the old firmware, we can now do that. Run strings on the original binary. See, there is a good amount of detail in it, a good amount of information in it. There, we see stuff like vaccines, rabies, sorts of good stuff. But again, since we have source, it's not worth all the effort unless reverse engineering is your thing. In my case, it is not. But now that we have the new firmware flashed, we can start doing all sorts of fun stuff, including stuff like starting a howl. So currently, the badge should be programmed to send a owl when I press the boot button, assuming Bluetooth wants to play nice. So we can see the normal broadcasts coming through. And if I press the little capacitive touch sensor, you should see a lot of different broadcasts. There we go. So with all the new commands that have been added, we can now just make it so that, hey, I can just press the booper and start a howl, and all of your badges start howling as well. We can send emotes, we can send rabid beacons, we can even send vaccines for rabies, all that good stuff, even custom commands. And a link to all of the requisite firmware scripts and info should be either in the chat or the description shortly afterward. That's about all we set out to do. Now, the important part is, what did we learn from doing all this? These same techniques used for basically just flashing firmware, they can be far more applicable to IoT devices than one might initially think. These same interfaces, this is just an ARM chip. A lot of these IoT devices that we're working with, just an ARM chip. So if we can pull the firmware off of the ARM chip on the device, now we have access to all of that firmware without getting a root shell, without any of that good stuff. I do not have to find any vulnerabilities in the device to actually get access to portions of its file system and its code. That makes finding new vulns way more easy. There's also other interfaces, again, like JTAG or SWJ-DP that provides even more access to the hardware. And there's stuff like serial breaking into bootloaders. But all of that is going to be covered in another live stream in the next week or two. But yeah, I guess that's about it. If you have any questions whatsoever, feel free to hit either myself or the entire IC team up on Twitter or our website. I'm on Twitter at extentbogon, like as in existing. Probably using. It's also our main Twitter name, I guess, which is IC Security, our website. But yeah, feel free to interact with us, and until next time, hope you found this at least somewhat enjoyable information. Until next time.